Hello everybody and welcome back to Regions Chemistry with Unit 8 Reactions and Stoichiometry. Today we'll start this unit with the first topic where we will be looking at the different types of chemical reactions. Now, whenever we have two or more chemicals that come in contact with each other, there's some sort of chemical change or chemical reaction that takes place. And some of the evidences that we can have to kind of know that a chemical reaction has occurred include a color change. We can also see some sort of solid, or we call that precipitate. We'll talk more about the precipitates in the next chapter. But if we see some sort of, like, we have a liquid and we see some sort of solid in there, then that could be an indication of a chemical reaction. If we see any gas that is released, so we can either see some bubbles forming, we can visibly see some gas releasing, anything like that, that could indicate a chemical reaction. If we observe that the thing, whatever our apparatus is, or whatever chemicals we are using to do an experiment or to look for a chemical change, if that thing is getting hotter, which means energy is being released, indicating an exothermic reaction. And if that thing is becoming colder, then that could also indicate a chemical reaction, and endothermic process, because the heat is being absorbed. And the 5 different types of chemical reactions that you guys need to know include synthesis, decomposition, single replacement, double replacement, and combustion. So let's get into all of them one at a time. So the first one that we'll be talking about is the synthesis reaction, which is an exothermic reaction, which means heat is released whenever a synthesis reaction occurs. And as the name indicates, synthesis basically means just making something. So a synthesis reaction occurs when we are combining two or more things. For example, let's say we have an element or compound A and a compound B. Both of them come together and they make a new compound AB. That's basically what a synthesis reaction is. So a quick chemistry example could be when we have sodium and chlorine, they combine together to make sodium chloride, which is the table salt that we use. And then another common example is when we have water, H2O, and carbon dioxide, CO2, both of them combine to make carbonic acid. And carbonic acid is a very, like, the biggest ingredient in the soda that we drink every day. Next up, we have the decomposition reaction, which is an endothermic process, which means basically what happens in a decomposition reaction is that we start with a compound, and then that compound absorbs some energy, some heat, and then it is broken down into two or more smaller products. They could be compounds or they could be just elements. So for example, let's say we are starting with compound AB, and then that would be broken down into element or compound A and B. So a common example is, we just looked at the carbonic acid. So carbonic acid can be broken down back into water and carbon dioxide, and that would be a decomposition reaction. Then we have a single replacement reaction, which is when we have a compound and for the most part, the metal of that compound is replaced by another metal. So for example, let's say we have this metal or element X and we have a compound AB. Now what's going to happen is that let's say X is a metal, so X is going to replace the metal in the compound AB. And remember, metals are always the first thing in a compound, so that means A is going to be the metal. So X will replace A. So as a product, we'll get XB. And then A, because X just replaced it, so A will just be left alone. So that's what a single replacement reaction is. And here's a chemistry example. We have a compound copper sulfate, CuSO4. So iron comes in and it replaces copper and makes iron sulfate, and then copper is just left alone. Double replacement reaction, however, is that when two elements replace each other. So they are not leaving, nothing is left alone, they are just replacing each other, or in other words, they are switching their partners. That's like an easier way to look at it. So for example, let's say we have one couple, let's call it a couple, or one compound AB, and then we have another compound CD. Okay, now what's going to happen here is that let's still go with the metals. So in compound AB, the metal is element A, and in compound CD, the metal is element C. So what's going to happen is that A and C are going to switch their positions. They're going to switch their partners. So now A is going to make a compound with D, and then B is going to make a compound with C. Okay, so that's what the double replacement reaction looks like. And here's a chemistry example. We have sodium chloride and silver nitrate. So sodium and silver in both compounds are replacing each other, and they are making a compound with the other partner. And lastly, let's talk about the combustion reactions, which occurs when we have a carbon-based compound, which means any compound that has carbon in it, and that compound reacts with oxygen. And when that happens, they produce carbon dioxide and water as a result. So here are two quick examples of what that looks like. The second one is actually methane, which is the gas that we use, that we have in our stove every day, and we use that to light up the fire. Now when that methane reacts with the oxygen in the environment, that's when it produces carbon dioxide, water, and that's how it produces that fire. So one common example of a combustion reaction that we observe in daily life is definitely the methane, and also when we burn the wood. So wood just reacts with oxygen in the environment, and it produces carbon dioxide and water and the fire. So um, if we look at table I in your reference table packet, which is right here, the first 6 reactions in this table are the combustion reactions. So we have a carbon-based compound reacting with oxygen, producing carbon dioxide and water. Whenever you see a reaction that looks like this, that should give you the indication that this is a combustion reaction. And that's it for now, guys. Take care. I'll see you in the next one.